All right, so we had a conversation about actual yield, right? Actual yield. The actual yield is what you actually get when you perform a chemical reaction. So, for example, if I have a chemical reaction, A and B combining to form C, and let's give some stoichiometry here. All right. If I know that I have 1 mole of A that is going to react this way, then I should get 1 mole of C, right? That would be what my theoretical yield, right? Theoretically, if I put in a mole of A, I should get out 1 mole of C. Okay? What if I put in 1 mole of A, but actually, because the reaction wasn't very good, the container made a mistake, or there were side products that I wasn't aware of, maybe I actually only got 0.5 moles of C. 0.5 moles of C. That would be my actual yield, right? So my actual yield might be less than my theoretical yield. Now, the theoretical yield should always be the most that you should be able to get out. So if you got more than the theoretical yield, something's wrong, right? Something's wrong. You didn't do your calculations right, or something just didn't work right. Okay, so if we look at this actual yield idea, we can also get what's called the percent yield. The percent yield. So I was supposed to get 1 mole, and I ended up getting a half mole. That's my actual yield. So my percent yield would be my actual yield over my theoretical yield. Right? I was supposed to get 1 mole. I actually only got 0.5 moles. Right? And then if I multiply that by 100, I can call it percent yield. A percent yield. Okay? So here's an example. You have a cookie recipe. It says it's supposed to give you 36 cookies. But in the end, it only gave you 24 cookies. So what's the actual yield for that reaction? The actual yield, the percent yield. 24 divided by 36 times 100. That would be our percent yield. Okay? All right. So let's skip forward here to a problem. Here we go. If we have 6.4 grams of methanol, CH3OH, and we mix it with 10.2 grams of oxygen and ignite it, we get 6.12 grams of carbon dioxide. And we want to know what the percent yield of the carbon dioxide was. Well, to identify the percent yield of the carbon dioxide, I'm going to need to know the grams of carbon dioxide that I theoretically should have gotten. All right? And then I see how much I actually got, right? It says right there that I got 6.12 grams of carbon dioxide. So I know how much I actually got, and all I need to determine is how much I theoretically should have gotten, and see what my percent yield is by taking what I actually got, dividing by what I should have gotten, and timesing by 100. Okay? So how do I know how many grams of carbon dioxide I was supposed to get? Right? How do I know how many grams of carbon dioxide I was supposed to get? Well, if you're remembering from last class, they've given me an amount for both reactants. So that means I'm going to need to identify how many grams of carbon dioxide I would get both with 6.4 grams of methanol, and also I'm going to have to do this again with my 10.2 grams of oxygen. Or in other words, they've given me a limiting reagent problem. See if you can find out how many grams of carbon dioxide you should be able to get by knowing these amounts of the reactants. Okay, see if you can finish that up, fill that up. All right, push pause right now. Take some time to do that. All right, take some time to work on that. I'm going to grab my calculator here. Okay, so if you're not finished, finish now. Take some time, finish now, and